So we come really a long way when it comes to animation. So, and therefore also picked like the Disney GIF, because yeah, there it's where it actually started, the beginning of all animation things, and they were really basic, right? It was frames, you're just showing 60 frames, or maybe they had even less frames a second, and then you have an animation. Animation on the web is actually not that much different from it. But in the really beginning, what we had was animated GIFs, just like what we saw it there. So maybe docs running on your website, or we had a marquee element that is duplicated nowadays, but still works. It's a magical element. And afterwards, you could do some animation with jQuery. They had an implementation, and what is nowadays more the standards are animation libraries. For example, Greenshook animation platform, or Velocity, or Anime.js. And well, everything becomes much more native nowadays. And you can maybe also remember that a couple of years back, CSS had a new level of treating this kind of things, and we had transition and we have keyframes, but we never really had a really good interface for connecting the CSS state with the JavaScript state. So they were not really easily to put in sync with each other. That was a big difficulty, to be honest. So you had like this super easy to pick up CSS standards, and they work, they're easy to implement, and they're really performant. But how should you control them with JavaScript? That was just not there. And that changed at the end of last year, because the Web Animations API, or also called like WAAPI, WAAPI, it just landed in seriously all modern browsers. So from WebKit, talking about Chrome, Brave, Safari, but also Blink like Firefox, and also Edge on Microsoft, they support it now. And this is what we're gonna talk about today, what you're gonna learn about. So first, I want to talk you through a little bit what the benefits are for your products, web applications, what the benefits are for the users. And also, and I think that's a quite important thing also for the development teams. We will see some technical implementation and some flashy demos, some basic demos and flashy ones, also on CodePen, and use cases in modern web applications. So to start it off, and you have to be honest about that, like a couple of years ago, the normal web development shifted towards like really heavy JavaScript websites. So the first React pages, I guess also the first Vue pages, were completely JavaScript driven. And at that time, maybe the development teams did not really realize, or it was so new. So they were putting a lot of JavaScript on the sites. But nowadays we are more aiming really on mobile first. So everything that you send to the client is actually way too much that you send. You want to send as less as possible. On the other hand, design is also developing further. And they also figured out that certain things in your user interface, they work much better for the user if they have an animation. For example, you have an accordion that goes open. You want to go from one step to another step, for example, in a checkout system. It's easier for people to see, okay, something moved from left to right, so I'm into a next step, or something moved into my shopping basket. You have a lot of different use cases where animation can help the user to understand what is going on. But then you also need to make choices. You need to figure out, is it worth putting a JavaScript library, even if it's a small one? Is it worth getting this into my project? And you also need to decide, do I want my team to learn that? Do I want this whole complexity? And on the slide, just like a wrap up of how much weight you add to your website in JavaScript if you use animation libraries. And it's not about blaming them for being that big. They are super useful. And I love to work with GZUP and Anime. But this is also the price that you pay for it if you use them. Another big thing about Web Animations API is you have to see it like the implementation that is in the browser to go from one state to the other. For example, if you have a keyframe, if you say, I want to move an element on the x-axis, it's natively baked into the browser itself. And a JavaScript library, what it does is it just writes, like in the best case, 60 times a second, it writes an inline style on the HTML node that you want to animate. But every time that you updating, that you're writing on the HTML tag on the DOM node, that's really cost intensive for the browser to calculate it, to update, to render everything, and again and again and again. You have to imagine that you're on your own, you're like super busy doing these animations, calculating it, but at the same time, you also need to do other things, right? You need to maybe fetch data, you need to validate a form, listen to other events on the site. And I have for you an example because I made a small stress test on how that actually looks like. I have now like 2,500 divs in this code pen, and I'm animating them with the Web Animations API. I'm not sure how you perceive that. You can always check back in the slides. There's the link, then you will actually see that this runs like super smooth. If you see that it's 2,500 divs. And I also made this test, but I disabled it for now, but I also made this test with Tween Max. And I hope my browser is not gonna crash. And I hope that you guys can see that. And it takes also a lot of time, but it's really stuttering. It goes really like in steps. You could see like, okay, it's maybe not even an animation. Maybe it's like, they made like a stepped animation also. So I think I have to kill that really fast. All right. That as a short demo, as a stress test over here. So that brings us to the benefits and difference actually that you have. So I think that the biggest thing next to the bits that you save that you don't need to load in as a client on your phone or on your laptop. But the big thing is you need to imagine that in the JavaScript world you have like one thread in the browser, right? You have instead you using workers and next to it, but you have one thread. But if you block this one thread with your animation, with your really cool animation to make your website really fancy, but it's blocking everything. With the Web Animations API, you don't have that. You gain a lot of performance because you don't write any inline styles on the DOM nodes itself. And you have quite a good support in modern browsers. So that really speaks for the Web Animations API. And there is at least like one big difference that I stumbled upon when I was starting working with it, and I thought, can I actually do the WebGL experiments? My things, my side projects that I like to play with. Can I also do that with the Web Animations API? And that is not possible because I'm not sure if that will ever gonna change, but I don't think so, because we are limited to animate DOM nodes. We cannot animate JavaScript objects as we used to do that in GZAP, for example. That's just not possible. But that's it. That's the only difference, and I would say like maybe reason against it to not use it. But then the next question comes, because writing a hover, like a transition, you hover over a button and it becomes yellow. That's a really easy thing. Do you want to have that in JavaScript written like an event listener? No, probably not. But so when should I use the web animations API, and when should I go for like a pure CSS solution? And I put together like a short list of, a really opinionated list of things where I think it's quite easy to figure that out. If you want to chain animations together like single tweens, for example, you have a mobile navigation. So say like first the menu comes in, the items comes in, then I'm firing a callback saying like I'm done. And because then I want to do something else. Maybe I want to throw confetti over the whole screen. This is really nice to do with the web animations API, because I know when I start, I know when I end, and then I have the things really in sync with each other. That's a really big advantage. I mean, you could also just somehow try to build that with keyframes, but it's going to be, even if you use extensions like Sass, I think it's going to be really a mess in your CSS. Another thing, and I will have a demo for that later, you can also jump and seek in keyframes. So just imagine you built an animation, but you can also say within the app, in the WAAPI, you can also say, okay, I want to go to 50% or to the end directly, or go back, or I can define the play rate if I want to. If I want a game, for example, to go play faster over time, that's also possible. Just try to reach that easily in CSS, also going to be a bit of a hassle. I can have multiple animations running in sync with each other. So to be really sure, okay, now both animations start and they're both run at the same time. A good reason to use the WAAPI is also if you say like, okay, I have now GZAP in my project, in my web application, and I can replace it somehow. I would like to replace it and just go for it, because it's possible. Instead of saying like, okay, everything in pure CSS will be a big, like really big refactor, and will just make my CSS a big mess. You can just write it in JavaScript and keep everything quite clean and organized. If you need to have randomized values for animations, for example, think of a particle system going from an organized system to a chaotic system. It's also much easier to do in JavaScript. You can modify keyframes on the fly if you want to. And also for really basic animations like toggle animations, again, like a mobile navigation, that's really easy to do in the WAAPI. You will see like in a couple of minutes, I will show a demo. Then you will see how much easier it is to do that with the WAAPI instead of GZAP. Time to have a drink. Okay, I want to show you some recipes. Are there any questions so far? I'd like to answer them also in between. You can just unmute yourself and ask if you want to. Okay. So like first, let's have a look at how you write it in code itself. Just imagine the node.animate, just imagine node is, for example, an H1. And you just define, just like you have it in CSS, you define, okay, for a transform, you want to go from an offset on the y-axis to no offset on the y-axis. And you want to also tween the opacity. And you define a duration for that and a fill state, so that it means it won't flip back anymore at the end of the animation. So something basic like this. Pardon. So it will be just like this. So we define an animation that just runs. So every time when I click the button, it just say, grab the H1 and transform it in this way. You even have more things, and there it becomes actually much more powerful. Just imagine you constructing a tween, just like you see it here in the first lines. And then you pause it, because if you construct such a tween, it will automatically run. For example, if you want to reuse this animation again and again, then it doesn't make sense to run it in the first place. So you pause it. And if you then connect it to a handler, you can always say, okay, I want to go back and forth. So like the first time I'm playing it forward, but every time when I'm clicking afterwards again, I'm just stopping it where it is right now and reversing it. So I'm not in the need anymore to figure out at what exactly point I am in the animation. I can just reverse it, just reverse play, back and forth, without any additional checks or complications in code at all. So I have here like a basic pen to show you that. So every time when I'm clicking, you see I can click like even fast, slow. It doesn't matter. And all the code that I need is this here, like really low complexity. But there are also use cases when you move an element from one part of your website to the other, and then you need actually to know what would be the style at that moment, the computed style at that moment when the animation is done. For example, you want to have it like position absolute somewhere, but where is it then at this moment? Where did I animate it to? So traditionally you would say like, okay, I get computed style of the element. So the browser needs to get the computed styles. You have to put it back into the DOM. Yeah, we don't have this anymore with the API because as you can see here, I said, I put an event listener on the animation itself. And when it's done, I say, please commit the styles. And what it does is it's magically takes the properties that you set in your keyframes, and it will just put them on the DOM element itself. And therefore is this demo. And as you can see, here is a div with class node, and it doesn't have any inline styles assigned to it. But we have here to cite the keyframes, and it says like, again, like a translate on the y-axis and some rotations and an opacity. So, and if I run it, at the end, we will have exactly these styles assigned in line to that element. So no need anymore to break your head about that. Where will it end up? What are the styles? It's just happening in that way. And there's also another big feature in the Web Animations API that is you have to imagine you assigned already styles to it. Just imagine you said like my element is already translated on the y-axis to a certain amount. You can combine them. Just think about it as merging them. So your JavaScript keyframes will pick up the element at the point where it is right now, and then move it forward. And that way you can combine it. It's not that it will flip to a certain point where you think it should start. So that makes it like really easy and really, really flexible to work with it. And one thing that I had like really a lot of fun with doing like preparation for this demo is, yeah, sometimes if you're busy in setting up an animation or a project, you also want to be able to debug it. You want to know how does an animation look like at every state of it, right? Every second, how does it look at 10%, for example? And what I did, I just used like a progress element and the values that I'm getting back there, and I'm assigning this to the animation and animation's current time, using this as a progress. So in that way, you can really scrub through it. But I mean, this is a demo. You can imagine, for example, to also combine that with an, let's say, an scroll position that you scrub through an animation, depending on how far someone scrolled. So everything that goes in a percentage, everything that you can normalize into a percentage, you can also use to control your animation or what kind of state it is in. Why? So now I have a problem. My excuses. So like this is this here. So I have a whole animation that goes like this, rotating, flipping back, and says, okay, I'm finished. But I also can just control it with my range input. So really easy, just click here, go back, and just see what's happening then. That's a really big advantage for when I want to debug, or if I have an interface where I want to run an animation based on user input on their progress. This is something that I think is really important for if you're talking about accessibility. Not everyone is reacting the same way on on motion on the web. So some people will really like you for switching off the animations. So because maybe they have a motion sickness, or it just takes too much time for them. You can also just catch such a situation really easy with globally just saying, if you don't want motion, or if you prefer reduced motion, then just switch off a duration or stagger moments. And I was thinking like, oh, this is really nice. So how can we play with that? How can we make something beautiful, like a nice experience with this kind of tooling, so that it feels like ice skating with your beloved one at the winter time? So let's skip to this once, and I have like one demo here for you, showing you how that could work if you think about the mobile navigation. So this whole animation here, just clicking, opening, and it can also be stop in between. So you can also just click like really weird, testing it, will it break? If I click like 100 times super fast on it, no, it just won't break, because it has the same basic techniques that I showed you beforehand. And it's also quite easy setup. It's just basically a navigation element with a list of page items in it. And we're just chaining them together at the same time. So every time when you're clicking the button, we're gonna play the animations forwards, or we're just gonna revert them. And we can also, because we're constructing it in JavaScript and just looping over items, we can really easily just add a stagger so as in delaying them. So I don't need to know how many items there are beforehand. I don't have CSS styling that is really written in stone. I can have like a minimal setup and have already such a good working animation. Another example for WAAPI that I was playing on lately is this one here. You have to imagine this is also like quite a lot of DOM elements that you want to animate in 3D space. It's also like really easily done with WAAPI itself. So it has a lot of good use cases for that. But until now, we actually just looked into, we just had to look into how is this with experimental things that is more demos. So how does it really work in the real world? How can I make a cool effect for that in the real world? And I had a look into that, and my inspiration for that was like an animated concept and design concept. I found it on Dribble, and I rebuilt that. So like this whole website, a single page website is built, animated with the WAAPI. And actually the coolest thing is this kind of parallaxing effect that you see here. It's a mixture of an intersection observer that checks if this element is in view, and then each of these columns has a certain delay attached to it. So it's a on-scroll parallaxing effect, but it's really performant. It's like way better than everything that I ever touched with libraries, or if you really heavily relying on the on scroll, you can just, that's a big advantage here. You can just say like, okay, I'm throttling my I'm just throttling my events, but still, because you're animating it, it just goes through like really easily and smooth. Also, this kind of blocks underneath, stagger them, flip them in. There's no extra big JavaScript library necessary for this kind of things.